Okay, coding session time. I got the tests open here. One thing I wanted to just touch on before we start. I mean, obviously we're going to continue with Bangalang. We're always continuing with Bangalang. But in the previous session, we switched over to using boomstick multi-threading for generating the vertices for our triangles each frame. But we didn't see a huge improvement in frame rate. Okay, so at the moment we're getting 1,000. So yeah, it seems really variable on my laptop. Because I think we were getting like 500 when I tested it during the video. Now we're getting 1,000, which is kind of more like it, because I think when we did the single threaded version, it was like 200. So it's like 5x, although we're using 8 threads. So ideally I would like closer to 8x if we're really doing the multi-threading efficiently. But we are not doing it efficiently. There's a couple of places where we just like spin on the CPU, so we're kind of using up some threads where we shouldn't be. And that's probably a big deal, a big reason that it's so slow. I mean, it's a lot faster, but it's still too slow. We'll deal with that later. Right now, because I'm really happy with where we've got to, like feature-wise, I really want to tighten things up. It seems like every session we're like plugging up holes in the language because there's just so many issues in it. And our test suite is really underdeveloped. So we're going to really work on that now. Just get the test suite a lot better. I imagine we're probably going to come across some bugs while we do it. We're not even running the test suite right now, it seems like. But it looks like it passed. Sometimes I disable it so that when I'm like debugging, I don't have to like debug the whole test suite. You know, I can sort of skip it in the debugging. And then I forget to uncomment it again. So what do we want to do? We want to like expand out this run test suite business quite a bit. So let's bring it out into its own file. And we just want this last procedure really. Run test suite. I guess there's a bunch of stuff we don't need. We need like format and OS, and that's about it. We'll take this out of here. Yeah. The other thing we're going to need to change is because actually we want to do a build and an exec, and I think we'll just like return a bool to say whether it was successful or not. Successful meaning that there was like return code of 0. Oh, and we should probably just call it test. But instead of passing in a file, because what I want to do now is, instead of right now we have like this big file with a bunch of asserts in it, I want to divide it up so it's actually running lots of tiny little programs that just test individual things. But I don't want to make a whole bunch of files. So I want to be able to build and just pass in some source code. So if we go back to main, so ideally we want to pass in like source here. Source, and I think I'm going to call that the out path, change that to out path. So pass in source to build, pass in source, source to compile. So compile takes in source. And this is where we actually read the file. So we're going to take this all the way up to the top. And go like this. And actually pass the striong, the source, in. All right. So that way we're passing the source around, and I also need to pass the name around, because we do kind of need to know what it is we're building or compiling. Probably need this again and compile. See here, when we tokenize, we need to know the name. So put the name in here. I'm still going to put this here, I guess, within compile. I mean, eventually we're going to create like a method of importing. So this won't need to be here. But for now we have this. And this would be just the source, I guess. Okay, so now we've updated that. We can go back to our tests. And I guess I'll make like a run test, which needs a name and a source. Like that. And in here, we're going to create a whole bunch of tests and run them, basically, and print out which ones failed, if any. And I guess we'll return false from here if any of them failed also. Which means that we should probably say, like, if the test suite failed, then we'll say like failed to run tests, or maybe just like test failed. I mean, this is only a temporary thing. Eventually we want to get rid of this, but it's just while we're developing the language, I think it's still quite good that we just run the tests every time before we run our main program. So then we're assuming I don't comment it out all the time, so that we can just make sure we're like always yeah, just make sure we don't regress, you know, and break things. So let's do some like I guess we want some maps. So we're going to have general tests. Oops, yet again, to change my keyboard. I always go out to the cafe or whatever and use my built-in keyboard on my laptop. But that built-in keyboard is a UK keyboard. So I always have to change. So comments, I want to test like this, that these comments work. So what I might do is just put like a line at the start, uncommented code equals 1, and put it down the bottom as, oops, underneath the comments as well. Just we have something there, like these should run successfully. If anything goes wrong with the parsing of these comments, then we'll probably end up in a state where like it starts trying to parse something that's not valid code, and so compilation should fail. So then we can go like for general test in general tests, run the test. Like so, basically. And then I guess we can do like or return. I don't think we want to do or return actually. I don't think we want to do or return. I think we just wanted to say like if the test failed, then we say success equals false. and we return success. Just because a test failed, we don't want to like quit out. We want to continue and try all the other tests. We want to test everything. So if I run that now, unsupported byte size. Okay. Byte size of, we're doing an assignment. The left-hand side is uncommented code with a type of number. Because we never provide a type, do we? So that should say, that should give us an error message like, could not determine the type of. And I'm pretty, yeah, there we go, could not determine type of. So maybe we should say like, if that equals nil, or the value is number. Maybe that's what we should be doing. Could not determine type of uncommented code. See, that looks much better. So right off the bat, even before I thought we would, I wasn't even expecting anything to go wrong there, but we've already fixed we haven't fixed a bug, we've improved an error message, which is something that I want to do. Okay, great, so let's just start cutting this stuff out as we replace it. So now it's kind of like declarations and assignments of various variables. So I'm going to call these, like these general tests are just like one-off tests. Then I'm also going to make some value tests, I guess. Value tests. I don't know if that makes sense. We can always rename it later. But the idea behind these is that that they're for testing a certain variable, I guess. So it could be called variable tests, but let's just name it like this for now. So it's like, could say like declare and assign. So this could be like var 0 equals value 0. That's basically it, declare and assign. Like that should work. I guess we could, put an assertion in there. I think I want to do it like this. That's valid, right? So then we could go like assert var 0 equals value. I don't think I want to print anything out, actually. We just want to make sure that this goes false. That's all. We don't really want to print anything out. So let's just do that for now. We'll just leave it an empty string. So I've said 0, value 0. So what we need to do actually in our value tests is, well, we need to loop through all of our types, basically. So we need to do it once with, so this is the source. So the source is like replace all. So like let's say bool to start with. bool source, like that. And then like for numerical type, numerical type and numerical types, we do something similar. But this time we're talking about numerical source, I guess. What's wrong with, I think we need like underscore, or maybe it's the other way around. There we go. Because there's 2 returns, replace all. Okay. So that should do it for all numerical types as well. But for numerical type, we want the value to be like 1. I think I should actually be like value 0. So let's see if all of our types can at least declare and assign. and the value has the value we expect. Failed to parse file at line 2. Column 10. Okay. Well, that's really not a very nice error message to start with. Let me just cut this out and see, like, is it the bool one that does this? Okay, the bool one does do that. So replacing value 0 with, because this is a value, so it should be, let's say, true. That would probably help. No, it's still unhappy. In that case, let's do printf line test source. Let's print it out and see what it says. Excuse me? We do that before we try to run it, right? So why don't I see that happening? Oh, it's in general tests. That could be why. Value is not defined. Yeah, so that should actually be value 0 again. There we go. Okay, it's happy with that. Ugh, I hate it when it imports like that. Okay. Oh, we do need strings. So let's just not have that terrible import. Okay. So now does it work for all? Could not determine type of var 0. Yeah, I guess so. Like when it's just a number, then we don't know the type. So I think we're going to do like type, this is bool, and then replace all in bool source. So that's numerical source, that's type, and that is the numerical type, I guess. How's that? Not redeclaring that. This would be a nice feature, I think, to put in my language. Don't really need it right now, but eventually it'd be nice. Okay. Segmentation fault, so something is unhappy. Is it during compilation? Yes. Okay. During the compilation of like some super simple, what is it, like var 0 number equals 1. Yep, okay, that would be a problem. But it shouldn't be that problem. This is not the problem it should be. So we're trying to get the type of number. Number should be a type. Yeah, but because of the way that I structure things, it is a bit difficult. This is actually a bit of a challenging one. So maybe I'll just I might put some notes in here of like some future tests to do. So the first one is like, this is like basically an unknown identifier as type. I think there should also be like value used as type and type used as value. I don't think I really check for that. You know, like if I tried to do like I8 equals false, I8 is a type, right? It's not a value. But I'm trying to use the type as a value in this case. That should throw an error. I don't know what's going to happen right now. Yeah, so right now I'm doing a bunch of, like, I guess you call them positive tests. They should succeed. But I want to do some negative tests where they should fail and confirm that they fail for the reason that I expect. But we'll get to that later. Okay, but right now, I think we just basically want to say like, if numerical type is number, continue. We don't do any tests with that because it's not a real type. Okay, so it's happy. Okay, so I want to declare and assign. I think another one we could try is declare then assign. So we like split it up so we can go like this. So it's split into two lines. And it's happy with that. The syntax highlighting is going a bit funny. That's all right. What else can we do? So we've got like this declaration stuff. And I think like this assignment stuff, I feel like this is like kind of sorted. So now it's kind of like arrays and pointers seems to be what we still have. So let's say pointer. So if we create a variable and then we say var1 is a pointer to var0, then dereferencing var0 should give us the value. Okay, I think that's kind of like a basic pointer test. Cannot dereference type bool in file pointer. Huh. It's because I should have var1 there. It feels like it's going slow array. I think because it has to compile and run all these tiny programs, the test suite is going to be a lot slower, which is a shame. I do want to get to like, you know, I would like to reduce the compilation needed because every time we do one of these tiny programs, it's going to parse and type check and generate, you know, it's going to do the whole compile step for this whole standard lib, even though we don't use it at all. So I want a way of like only compiling what is needed. Okay, so now we have basic pointers. I want arrays. So we can say like type 10. Sorry, there's a bit of noise outside. And then we can say 5 equals like value 0. And then we can just confirm that that is correct. So that's a basic array. I guess that's like declare then assign array. That's more or less what's happening. And I guess that's declare and assign pointer, because we're like doing it in one go. But you have to have something to point to first. So then does that mean we should have a declare and assign? Well, we can't declare and assign with arrays. We don't have the ability to do that yet. I guess we could add an array literal thing. I haven't really thought about that. I do have like a list actually of things I wanted to, oh Jesus, I thought it was gone for a second. Things I wanted to add. And I did say struct and slice literals. So let's say array literals. I guess you could also have like a kind of a slice. Let's just call it array. And say and for slices, maybe. Make a note of that. Okay, let's try that. Yeah, it's taken a while, hey. So declare and assign array. And then it's kind of like declare and assign pointer to array. Oh, declare then assign. Let's put that up. Oh. Okay, I guess I had duplicated that. Then declare and assign pointer to array. So here's creating my array. Then a pointer to an array. So then we should be able to just do this because this will also test the auto dereferencing. You know, you might think that we need to do something like this, dereference. I think that would work. That should work. I mean, let's see. Wow, took so long. Yeah, see, that's valid. I'm just manually doing the dereferencing, but you don't need to do that. It should just work. Maybe I will end up splitting this out so it's not part of happening on every run because it's so slow. Declare and assign pointer to array. Okay, so I think we're kind of done like, so these are just like arrays, pointers to arrays. I think we're kind of done all this stuff. Okay, so we move on to, this is like comparison stuff. So for Booleans, we have this sort of comparison stuff. So value tests, I guess these value tests could be for like any kind of type, basically. Which makes me think, like, what are our types? They're basically all numbers except for bool. String, I'm not going to do these tests for because you can't really manipulate strings like this. Yeah, I'm just going to leave strings out of it for now, and C strings. So that's basically it, and procedure is something special. So it's basically just numbers. We have numbers and strings and bools. That's basically it. And strings I'm not really going to test. Or not much anyway. I don't think we can really do any assertions as it is right now. So now I want to have like tests that are specific to different kinds of variables. So we could say like bool tests. I guess, yeah. Let's try that. Let's see what happens. So bool tests, and then we add to the bool tests. See, now what I'm starting to think is like these to simplify these loops, but no, let's not try and do anything tricky right now. So equal. So if I say value 0, I'm just going to assert that value 0 equals value 0, basically. That's equal. And not equal, so we have a value 1. We'll make that different, and they should not be equal. And that's basically this test here, right? So then we'll go down here. Am I missing something? I think that's all good. It just messed with the indenting, but I think it's okay. So that's the bool test. Boom, boom. Bool tests. Here we need a value 1, which I'm going to call false. Wow, takes so long. And now I'm going to say like numerical tests. They also have the same thing. So they will take care of this. But now see, here I was using literals. So these were implicitly F64s. That's what the compiler will interpret them as. But now that we're going to go through every single, well, here we could just, so these are literals. Here we can't just use literals like this. We need to actually make vars. Otherwise, like I just said, it's just going to interpret them as F64s. We're not going to be testing every type, and we want to test every type. So we need to do something like this. I guess we don't actually need var1 here, but we do here. And maybe just for consistency, we'll do this. Okay, so now let's make some, copy this to here, and we'll make some purely numerical tests. Numerical test. And here we need to have a value 1, which I'll call 2. And it takes forever, but it works. Okay, so now we have like our less than, greater than, less than, greater than, less than or equal, greater than equal. So let's try those out. So less than, we have 3 asserts. So how do we do this? I guess, I know this is weird that I'm doing this, but I'm just a bit of a stickler for like consistency. And it seems like I was doing var 0 on the left. So 1 is less than 2. 1 is less than 2. 1 is less than 1 is false. And 2 is less than 1 is false. So that's when we switch it around. So that's less than. greater than, I have the same numbers and the same, but now we do greater than, and we say the first two are false, like that. And then we have less than or equal. So we can cut those out now. So I think these are like the same order again, but it's only the last one that's false. So we go like that. And then maybe I'll say greater than or equal. And I think it's only the first one that's false. Let's try that out. Very slow. Very slow, but successful. So that's all that done. Now we have all these kind of arithmetic tests. So we have add, I believe that's the first one. Oh, well, this is negate actually. Negate. So here we have 4, 2, and 6. So I think I might actually just change this up. 2, 4, 6. So when we negate, we need to have two values, and then we basically kind of like do this assertion. So it's like -2, 4. We don't need to change this one because it can be inferred from this. I guess we only need to have one, which is an actual variable. So add, I think, is like, yeah, just like that, but now it's 6. We should probably put it like that. And add a sign, which I don't think we were actually testing before, but let's add that. So this is where I guess I go like plus equals 1. And then I say var0 equals 3, because var0 is 2, right? Var0 is 2. So add a sign. And then, well, subtract and subtract a sign. So minus equals 1, so that'll be 1 now, and 4 minus 2 is 2. Yeah. And now multiply and divide. We don't have multiply equal and divide equal, but we probably should. Do we want to add that now? I'm thinking like, why does that not exist? It's on my list of things to add. So let's add it. Test-driven development, you could say. Wow, that's some fancy shit right there. So I'm like times equals 2. Maybe I'll make all of these increments 2. So that'd be 0, and then that'd be 4. So 2 4s are 8. 2 times 2 is 4. Divide and divide a sign. So 2 divided by 2 is 1. 2 divided by 4. Whoa. So var 0, yeah, var 0 is 2. Var 0 is 2. So this is 4. 4 divided by 2 is 2. And 4 divided, and 2 divided by 2 is 1. Okay, I think that's right. Let's see what happens. Takes a very long time. Failed to generate expression. Oh, right, of course, because we don't have our... and with floats. With floats, we never implemented it. Plus equals or minus equals. It was never implemented. Okay. Well, we're going to need to start from the beginning, right? Tokenization. Let's go to our tokens, because we're going to need asterisk equals and backslash equals. So then in our tokenization, we have our list. Here we go. Like that, so they're proper tokens. Parsing, we need to add them. Yeah, our precedence, we need to work on the precedence for these things because it's not right. So it would be done here. Asterisk equals backslash equals modulo equals. Yeah, I guess modulo equals as well. We don't have any tests for modulo. Let's do it. So we're adding some features here a bit. But just to round it out, I feel like it should be... yeah. It kind of feels like something's missing if we don't. So let's go back to tokenization, because we need percent equals parsing. So okay, so we have it in our binary operator precedence, and I don't like the, I don't think that it works very well, but that's enough for now. Asterisk equals is multiply assign. Backslash equals is divide assign. Percent equals is modulo assign. Divide assign, multiply assign, modulo assign. Okay, so that's that one done, this one done. Now here we need asterisk. So this is saying that these are all operators, binary operators, to be more precise. Basically just a list of binary operators. So that's the parsing done. Type checking, I think, should not actually need anything more. I mean, atomics are going to throw an error an error that's not very nice. We might need to clean that up. But then generation, we definitely need to fix up. Okay. And modulo doesn't work for floats also. Now, because of the way we do this with our SSE instructions, we can't put a memory address on the left-hand side like we do, like in our integer stuff. That's how we do it. We just keep the left-hand side location here, and it just works. That's not going to work for this. So yeah, instead we use a register explicitly. And I think what I'm going to do is put add assign subtract assign, multiply assign, divide assign. So they all do the same thing. But then if it's one of these assign ones, if we're doing an assignment, I think basically I want to copy back to the left-hand side. So I want to copy from that result location back to the left-hand side location, and we have to supply some more stuff, right? Type node and a context, I think. Is that? I feel like that's right. Yep. Okay. And then we need to say like actually the left-hand side is where, no, the result is the left-hand side. That's what we want to return. So we copy our result to our left-hand side because we're assigning to the left-hand side. And then we say that's what our result is. So I think that works for floats. With integers, we can be a bit more efficient. Yeah, so with integers, we do something a little bit different. So multiply assign should be the same thing, just with imul, I think. And then divide assign. Well, divide assign is like, we're going to have to do all this anyway. It kind of just changes this line, I think. It changes where we assign to. So the result location. So I think basically we can say like, modulo and divide all of this. And then we can say like, if the node type, right? If node type is divide assign, or node type is modulo assign. So if it's one of the assigned ones, then we do this. The result is the left-hand side. So this line should copy it back to the left-hand side location. And we return the left-hand side location. I think that should work for divide. Yeah, let's see. I think we're going to get some errors because certain types cannot perform certain operations. We're going to get ugly errors from that. Yeah, here we go. Invalid type atomic I8 in file multiply. Yeah, so basically it's saying like we can't multiply an atomic. So we kind of just need to skip those tests for atomics, right? But we can add and subtract. If we come across an atomic integer, we can do all the comparison stuff. We can do add assign and subtract assign. That's it. So I'm kind of surprised that it didn't fail earlier. So in here, what kind of checks do we say? If it's a comparison operator, no, those are not the checks. We can't do arrays or slices. Atomic integer type. Okay, atomic integer type and not comparison, and not added a sign, and not subtract a sign, it's no good. Yeah, that sounds right. And that's why we get this invalid type, which is horrible. I guess we could say like binary operator, and then put in the operator name. Is not valid for atomic integer, and then we give the name of the atomic integer. Binary operator add is not valid for atomic integer. We'll just say for type. I think that's valid. I think that's okay. So that's much better. Not numerical type. So I think we can also do this. It's much better than just saying invalid type. It's actually saying that binary operator is not valid. Yeah, and I guess we'll just copy this in here. I maybe could do better, but I think that's pretty good. Okay, so add is not valid for atomic integer. Makes sense. So what is valid? We can negate, and we can do the comparisons. Yeah, that's kind of annoying. It's a little bit difficult to like restrict this stuff. So it's in the numerical tests. So I kind of want something like this. So for numerical type, this is going to be super inefficient, really. These loops should be around the other way, maybe. But this will do for now. So we want slice.linear search. Atomic tests. Like that. What is that the bool? No, I think we need to go the other way around. So then we need atomic integer tests. We can make it a string slice. I'd like to be able to do this in my language too, that we can just make a slice like this. But in Odin, the brackets go on that side because it's weird. So here I'm going to say we can do like equal. Yeah, I don't like this because now we're going to need to like opt into everything. So maybe we do non, so it's like opt out. Because then when we add tests, we need to opt out for them. And I think that's a better idea because we'll explicitly need to do that. Whereas opt in, we won't get an error or anything. We just won't be testing when maybe we should. So subtract, multiply. And that's divide and modulo, which I have not actually So if it's a non-atomic integer test, well, I guess we also need to go like atomic integer types. Numerical type. Yeah, I think we need to review the structure of these tests, because I think this is going to be pretty slow doing this all the time. So if we have an atomic integer type and it's a non-atomic integer test, then we skip it, I think. And we realized that we needed to have like a modulo test. Modulo and modulo assign. So what is it, like 4 modulo 2? That's not really any good because it divides evenly. So if we say 4 modulo 3, then we should get 1. Yeah, 4 modulo 3. So 4 modulo equals 3 should also be 1. Let's try that. Invalid combination of opcode and operands. Test line 13. That should be valid. Register memory. Here's IML here. See, register memory. It should be, it looks good to me. Why would that be an issue? This is the way I've been doing multiply the whole time, right? Oh, I should probably just do like this. Okay, yeah. So we have so multiply and multiply assign. So that one's explicitly a register. So it's not that one. It must be this multiply here. Or there's another multiply down here. But that's multiplied by element size is the comment. And here we saw this one. So it's this one here, which we have not modified. And we've been using this whole time to multiply. I guess I've never multiplied, because this R11B, that means it's a single byte. So I guess this is the I8 test, which I think I've never multiplied I8s. Let me just see if it's like an I8 thing. Where are we? Tests. Numerical tests. So if it's I8 and the numerical test is, what is it, multiply, then we skip it. Now what happens? Segmentation fault. Well, that's worse. Hopefully it's in the compilation. It is. Oh, we've got an infinite loop. Okay. Type check expression, type check primary. what is our primary? Multiplier sign is not a primary, and I know why it's gone in here. If we go back to expression 1, here we go. This binary operators list needs to include our new multiplier sign and divide assign and modulo assign. Let's try that again. Then we come back to this. So now we're doing a multiply where we have memory and this. So is that legit? Like we're not allowed to have memory here? Maybe, because it says register here. Just register. So maybe that's legit. We can't do that. So that must be multiply equals that we're trying to do now. With a D, so that's a double, so that's a 32-bit, right? Yeah, because we're allocating 4 bytes, 32-bit. So yeah, I guess we can't have memory on that side. So when it comes to multiplier sign, we can't just do this pattern. It seems like it worked for addition and subtraction, but multiply, it does not work. So we can do, what's our result locations? That's copying the left-hand side into a register. That's what we often do. So maybe we need to do that still. And then do the multiply with that. Yeah, I guess we need to do that. And let's see what happens. So we get some assertion faileds. But we never record. Yeah, we never record what failed, actually. We should probably do that. Failed to type check primary. var1 is not defined in file subtract. So if we go to our tests, subtract. Oh, that should be var1. Multiply and divide, they seem to have it correctly. Okay. But some assertions still failed. So we need to do a better job of recording it. So we need like a failed tests, which I'm just going to make a dynamic array. And then we just do an append to failed tests, the general test. Here we need to do like a format, is it aprintf? So then we can do like the name of the test, and we can also say it's for Boolean. And here we will say the numerical type. And these are bool tests. So say, oh, but I'm saying Needs to be ball test. Yeah. And then down here, we have another test. So that would be the numerical test and the numerical type. And then we return the failed tests. Where are we? Way at the top. So I guess we could just do something like this. And then at the bottom, we'll just say return. And then in our main, we can say failed tests. And if length of failed tests is greater than 0, then we say failed tests, and for failed test in failed tests, we can print out the result there. So we'll do a print f line, so I just want to indent a little bit. Like so. Let's see what happens. Failed to type check primary. Var1 is not defined in file add assign. So I still have an issue there. It's a quality, add assign. Oh, that should be var0. Binary operator add is not valid for type atomic I8. Did I not fix that? If it's an atomic integer and it's a non-atomic integer test, then we skip. One of those tests is add. Is there somewhere else where there's an add? Negate has an add. Negate has an add. So let's for now skip negate. And just put a comment there to say, like, we shouldn't really be skipping this. But we'll do that for now. Some failed assertions. Invalid combination again. Okay. So that's line 10. Multiply. So this is bytes and bytes again. So this is, I guess this is multiply assign. So it really doesn't, so it got past, it did it for all the other types, and now it got to multiply assign, and again it's saying like, no, not with this. So maybe this is really, I'm gonna have to look this up later because this is really weird, I think. I don't know why you would not be able to do multiplication with 8-bit numbers. Doesn't seem right to me. So we'll take out multiply assign there. We should still get issues with modulo for floating point numbers. And we have assertion failed. And we have failed to generate expression. Oh, that was probably with the floats. I don't think I actually type check it. Yeah. Modulo. Yeah, okay. So we are fixing a few things up, tidying a few things up, which is nice. And we've added some features. So I think maybe we're over an hour, so I think I might just try and do this, and then we'll try and do these bed mass tests, and we'll call it a day. So really, we've taken all of these tests and we've spread them like across all of our a lot of our types. So we've already improved our test suite. But yeah, I want to add a lot more tests. So probably in the next session, we'll add a bunch more tests as well, and fix up any issues we find then. So in type checking, let's fix this up. So float types. If it's not a numerical type, then we're in trouble. And if it's a float type and we're talking about modulos, then that's not valid. Those are like the only operators we can't do with floats, I think. So we should get that error now. That's right, we have these failed assertions we need to deal with too. Failed to generate expression. That should be or. It's obviously not going to be both of those values at the same time. That's not possible. There we go. Binary operator modulo is not valid for type F32. Good. So then we'll have some more exclusions here. Yeah, I think we want to invert these loops. So then we can just do we can do these searches just once instead of for like every test. Yeah, this is probably very, very slow. Float types, so if basically the same condition here, right? Except it's more like, I guess it's more like this. Modulo. Do not do modulos for floats. Okay. We still have failed assertions. So hopefully we get to the point where we can see what tests are failing. Okay, divide assign, multiply assign, modulo assign. Okay. So the assignment ones, I guess I got that wrong because this is some code that I changed. So for floats, it's all good. This float code seems to be all good. It's the signed integers where it's all going wrong. So add assign, subtract assign is fine. Multiply assign, we copy the left-hand side into a register, which is the result location. We copy the right-hand side into a register. And then we do our multiply. So then the result location which we return, but it's a register. Okay, sorry. Sorry, yeah, we need to do our copy, kind of like we did for floats, which I guess is above. Yeah, for floats, we had to do this like this business. I think we have to do this for multiply as well, because it's in a register now. It's not in the original place. So we need to copy the result location back to the left-hand side location and then do that. Because we can't have a memory address here, can we? I don't think so. I think we came across issues with that. So that should hopefully fix up this multiply assign business. Modulo, It's I8 again. Interesting that just for I8 it's not working. We might just put a to-do for that as well. So divide assign just for any kind of integer just does not work. So I think I failed there. So I tried to say if it's this, then the result is the left-hand side. And that's where we copy at the end. Shouldn't that work? That actually looks legit to me. We copy into the result location, which is the left-hand side location. Okay, so I think we've fixed multiply assign, modulo and modulo assign. Let's avoid those for I8s. Just put, we've got the to-do already. But it's this divide assign that I'm a bit stumped by. Basically all I did was add this, right? So if we're talking about a divide assign or a modulo assign, then we say the result location is the left-hand side location. It seems to happen for, it works for modulo assign. It works for modulo assign. What? But multiply assign, no, but divide assign it does not. How does that make sense? Unless my test is wrong. Unless my test is wrong. Divide assign. 2 divided by 2 is 1, right? And value 0 is 2. Value 0 is 2. So value 0 goes into var 0. Divide it by 2, we should get 1. We don't have the correct test here anymore. That's a bit unfortunate. I just want to get this one. I think maybe we'll, because we've been going quite long already, I think we'll actually leave these bedmass ones for later. I just want to hopefully get this last thing nailed. I'm so confused why like modulo does work, but divide assign does not. That really makes me think like that we're outputting to the right location. We have to be. But we're not. Divide, modulo, divide, divide, modulo, divide, divide, modulo, divide, divide, modulo, divide, divide, modulo. Where's a divide assign? That's what I want to see. Come on. Maybe I'll put a breakpoint here, actually. That's probably a better idea. Okay. So divide assign. The left-hand side location is a memory location. It's the top of the stack. So the result location now is the top of the stack. Should be copying from, I think it's Rex or DX. Ah, that's what it is. Ah, wow, okay. Because for modulo, you need to use DX as your, like, divide and modulo, they both have the same thing going on. So maybe I'll also say, like, better for the comments. Operation name, output register, and then we'll do like another if. So the problem here was that if it's divide, it was using the AX register, which is where, so when we do a divide operation, it's going to put the result of the division in the AX register, and it's going to put the modulo, the remainder, in the DX register. But because for divide assign, because we just had this check, it was going to this register and giving us the modulo result. That was the issue. So I guess we can take this out. So if it's, oh no, we'll put that there. Yeah, we do need to keep that. So if it's an assignment, then we update that. If it's divide or divide assign, well, I guess modulo. If we're doing any kind of modulo, then we update the operation name to modulo, and the output register is DX. DX. So we're going to default that to AX. So actually maybe, because it feels like a waste to do this whole register creation thing, so I'm just going to say like AX DX, that's like the output register name. Okay. And we changed the operation name because I wanted to, I guess it would be the last parameter in each of these. Then I'm going to do like that. So we know whether it's a divider or a modulo when we print out the assembly. Okay, I think that should hopefully work. Fingers crossed. Well, it's already failing because that needs to be a declaration. Let's try that. And now we can be sure that we're like not breaking any kind of division or any kind of modulo. Yeah, all right. Everything worked. Okay. Yeah, that was actually quite a long session, so I think we're going to stop it there. But I think we did pretty good. We got a lot of tests improved, and we can, like now we could see where there were issues that we didn't realize before with different kinds of types. Like this is still something we need to figure out, this I8 stuff. Yeah, but I'm happy with that. Okay. Thanks for stopping by. Have a good one. Ciao for now.